Hello guys, welcome to Books and Code, and today we are going to solve a really very interesting problem, that is good stones. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you never miss out an update. So let's move on to the problem. The problem says that geek is in a geek land which have a river and some stones in it. Okay, initially geek can step on any stone. uh, each stone has a number on it. Okay, so there is something like river and we have some stones, so we can move to any stone, and each stone has a number on it, uh, representing the value of exact step the key can move. Okay, so the stone have a number like 2 3 4, and it represents the step that we can move. If the number is positive, then geek can move to the right direction, and if the number is negative, then geek can move to the left direction. Okay, so if the number is positive, then geek can move to the right direction. Like if we have here negative number like -3, so geek can move in the backward direction, and for positive he will move in the forward direction. Okay, so bad stone are defined as the stone in which if geek steps will reach a never-ending loop. Okay, whereas good stone are the stones which are safe from never-ending loops. Return the number of good stones in the river. Okay, so it's kind of if geek is stuck in a never-ending loop, so he's never gonna cross the river. So we need to help him to find the number of good stones. Okay, so let me explain you the problem statement clearly. Like, let me take this example. So the example says that we have an input array, and it consists of 2 3 -1 2 -2 4 and 1. So these are the stones, and now from this stone, the first stone, we can move to the second index. So from here we can move this index. From this 3 we can move 3 step forward, so we can move here. Now from this one we can move here, and like this we can do. For this 4 we cannot move anywhere, so we'll cross the river. So these are representing the river, and we'll just get out of the array. Okay, so we need to give the count of the good stone. So let me explain you. Here the problem is explaining what exactly a bad stone is. From these two, we are going to, let me change the color. From this 2 we are going to this -1, and from this -1 we are going one step backward, so we are going here. Now from this 3 we are going to 3 step forward. From this -2 we are going 2 step backward, and now we have reached a point from which we have already visited. So this is something that that should not be there, because now we are stuck in an infinite loop. So we are not going to count these stones, like this -2, this -3, this -1, and this -2, this 2 3 -1 -2, and rest of the stones are good stones, like this one. Let's see how. From this 2 we can move to 4, and from this 4 we can move out of the array, and similarly from this one we can move out of the array. So these three are contributing to actually these are not contributing to any infinite loop, so that's why these are good stones. Okay, and this can even help geek to cross the river. I hope you are clear with the problem statement, and let me move to the solution now. Solution. So the first thing that is coming to my mind after looking into this problem is, like, let me write the array here: 2 -2 4 and 1. What we can do is we can start from this 2, and from this 2 we are forced to move at only one point, that is -1. So we will move to -1. From this 2 we'll move to -1, and now I'm currently at, and I will mark this 2 as true, I mean visited. So it is visited, and now I'm at this index. So I'll write 2 3 -1 2 -2 4 1. I'm at this index now, and this 2 is visited. Now from this 2, what we can do is From this, from this -1 we can move to this 3 because we have to move one step backward. So we are going to visit it as true and moving our pointer to 3. Let me do this. Now I will mark this as true, so this will become true. So our array will look like something like 2, then -1, and rest are 3, 2, -2, 4, 1. Okay, so now I'm currently at this index, and from this 3, what I can do is I can move to 3 step forward like this 2 and visit this 3 as true. So let me undo this. Now we have visited this 2, this 3, this -1, and now -2, 4, 1, I'm at this 2. Okay, so from this 2 we can move to -1. Okay, and mark it as 2. So from this 2 I'm visiting 3, -1. Okay, actually I made a mistake. -2, and now it is not visited yet. Now this is the point, this is the break point. You can notice here that I'm at a point which is already visited, so this time I have to return a value. I have to return bad. I'm going to return bad, so this bad is going to pass to this through backtracking. After that it is going to pass to this 3, and this is going to pass to this one, and then to this 2, and this 2 is going to have a value that it is a bad stone. So now as we know that 2 is a bad stone, so we are going to move our pointer to right, and we are going to do this for all the indices, and then we are going to count how many bad stone we have, and then we can simply get how many good stone we have by subtracting the length. So this is what we are going to do. Like, let me take, this is for the 0th index. Now let me do the same process for the for a stone that is a good stone. So I will have something like 2, 3, -1, 2, -2, 4, 1. So I'm going to do this step for this 2. Okay, so from this 2 we can move 2 step forward, and what we can do is we can mark this 2 as true, and rest will remain same. Now this will become -2, 4, 1. Now my index is at, current pointer is at 4. After that, what I'm going to do is I'm going to visit this, mark this 4 as visited as well. So now this 4 is visited, 2 is visited, and rest are not visited, like 1, -2, 3, 2, and this is going to somewhere at this point. And now I realize that this point is something that is out of the array. So we can say that the stone from which we started is a good stone. So we are going to return good to this 4, and this 4 is going to return this good to this 2. So we got that 2 is a good stone. So it is kind of recursive approach where we are starting from a point, and then we are asking from the next index that whether it has the value good or bad. So if it is bad, then this 2 is going to be bad as well. Let me explain it in a better way. So 2, 3, -1, and 2, 3, -1, 2, -2, 4, 2, -2, 4. What we are going to do is we are going to start from this index. Now what this index gonna do is it is going to ask from this, the next position, that hey, are you good or bad? So if it is like bad or what, so if it is bad, then this 2 is also going to be bad, else it is going to be good. So whether 2 is good or bad, it totally depends on the next step that 2 is going to take. So it's kind of recursive solution where I will calculate my next index as my current index plus the value. So array of isn't it? After that, as I got my value, I'm going to ask that, hey, I'm going to ask, so I will have function like solve function. I'm going to ask to the next index from this same array. So this is what I'm going to do. So it's kind of recursive approach, and let me write the, this is recursive approach. And so I will have a function that is solve, and I will have an index and an array, obviously a visited array as well. Now what I'm going to do is, oh, actually I don't need to do this. What I'm actually going to do is, I'm going to check the man is not working. I don't know why this is not. So here I'm going to check if my I is, the current index is smaller than 0 or current index is greater than length. This time I'm going to return good stone. So but if this is not true and my current index is visited, then I'm going to return bad stone. And if these conditions are not true, then what I'm going to do is, I'm going to check the next index. So my next will be something like current I plus array of I, and I'm just going to return the value return. But before that, we need to mark visited for the current, and after that I'm just going to return the value. So instead of even call the function and return the value store the value somewhere, like answer variable will store this value, and I'm going to solve for next and array and visited. After that I'm going to mark visited as false. Why I'm going marking visited false, let me show you here. Because when let's consider this case, why I'm actually backtracking. So when I go from this 2, when I go to this 4, then I mark this 4 as visited, as you can see here, and then I'm going here. So after that, when I'm done with this particular index and I check for this index, then it is already visited, so it is going to tell me, hey, it's a bad stone, but it's actually not a bad stone. So that's why I'm marking this visited as false after traversal. This is a recursive approach, so let me code this approach and let's see uh, what else we can do. So it was recursive approach. Now let me code the approach. So this is the problem at Geeks for Geeks you can find. Even I'm going to provide the link in the description. So what I'm going to have, I'm going to have a visited array. I will make it a boolean array. So it is going to be a boolean array. After that, what I'm going to do is, I'm going to traverse the whole array that is given to me, and if my current index is not visited, then I'm going to call the function for the current index. Now this function is going to return some value. So if the value written by function is 1, then I'm going to add it to my answer. So I'm going to store it somewhere, and if value is equal to 1, then I'm going to increase my answer, and I will have answer value. Well, basically one represented, let me write. So I've written the answer. So let me write here 1 represents good stone, however 2 represents bad stone. So I'm just using any of the number. You can write here 3 or 4, doesn't matter. Now let me write the function solve here. So it is going to be public static int. Okay, not good stone. Solve. I will have int I array and a boolean array that is visited. Okay, so let's see what we can do here. Before that, okay, so I'm going to write if I is smaller than 0 or I is greater than equal to the length of the array. So if I have reached this condition, then it's good stone and I'm going to return 1. So 1 means here stone. Else if my I is already visited but we have not, it's not a good stone, so it's a bad stone. So I will write it bad stone. Okay, now I'm going to mark current index as visited. After that, what I'm going to do is I'm going to find my next index. So next index will be I plus the current index plus the current value of this stone. After that, I'm going to call I will call it return value, and I'm going to call the function. Actually, I'm storing it somewhere because I need to do something like visited I equal to false here, and then I have to return the value. Okay, so here I will write next array and visited. So this is the approach. Let's see whether it works or not. I think it should work. And okay, so it's working. For example, test case. Let me submit the solution now. Okay, it's working, and let's see. Okay, it's giving me time limit exceed. It's giving time limit exceed. Let me see why it's giving me time limit exceed. So what we are actually doing is, so this is about recursive approach. We're done with recursive approach. Let me see what improvement I can do here. I don't know why it's giving me time limit exceed. So 2 3 1 2 minus 2 4 1. What I'm doing is, for this 2 I'm going to this minus 1, and from this minus 1 I'm going to this 3, and from this 3 I'm going to this 2, and from this 2 I'm again going to minus 1. After that I'm returning the value. Okay, so this 2 becomes a bad stone, but the problem is all the stone included in the traversal are bad stone as well, but I'm not marking them as bad stone. I need to mark them bad stone so that when I come to this index I don't need to do the same process again. Like for this tree I'm going to this 2, but this 2 I have already processed this 2, so I need to store the result somewhere. So okay, so it's actually a dynamic programming problem. So it's quite surprising that it's dynamic programming, guys. Okay, so what I'm gonna do here is I've just explained you how it's a dynamic programming problem, because we have overlapping subproblems like for this 2 3 1 2 minus 2 4 1 minus 1. So when I'm done with this, like I have already solved the subproblem for this, so subproblem for this will be represented by solve like I plus array solve for 2 and array and visited. And when I come to this index, since you can see here I'm using a loop, even which means I'm traversing for every index. So when I come to this index, then I have already solved that problem, and here I am facing an overlapping subproblem. So we have something like overlapping subproblems. Okay, so what else we need for a dynamic programming problem? We need an optimal substructure. Okay, so I have already explained how the problem is like following the optimal substructure. Like at each time the problem is depending, the solution for any of the index is depending on the next subproblem. So that's how it is following both the criteria. And now we are going to apply dynamic programming here. So what I'm going to do is I'm going to use memoization technique. So let me write int. I'm going to declare a db, and even I'm going to make an integer array so that I can store null in it as well. So my dp will be equal to new integer and n. So I'm going to store my answer every time, and let me write here whenever my visited is true, then I'm going to store it here. Also let me write one thing here: if my dp of I is not equal to null, then I will return dp of I. Means dp of I is storing some answer, else we need to store the answer in the dp array. Let me see whether it's working or not. So this is all about memoization approach. Okay, it's giving problem. It should be static because we are accessing a non-static variable from a static method which cannot be there. So it's working for example test case. Let me submit the solution. It should work, I think. Okay, so okay, it's giving me time limit exceed. What we can do is, before checking this, we can, okay, so let me make it actually small. Let me possible that it is giving me exit because of this. Now let me fill my deep array with -1, and what else we can do? While dp is I is not equal to -1, let me submit it. So okay, let me check. Okay, so it's working now, and this is all about the problem. I hope you like the solution the way I explained it. So what I have explained you is, I have explained you the problem statement and the recursive approach and the dynamic programming approach. So I hope you like the solution. If you like the video, then you can hit the like button, and this is all about this video. Thank you.